Okay, Else, I think you can start with the logistics.
Yes, thank you, Thierry. Good afternoon, everybody, and welcome to this afternoon's workshop, a workshop that SEN, together with ASD STAN, is organizing a workshop about the unmanned aircraft systems direct remote identification. So we are having this workshop as an online workshop, of course, which entails some housekeeping rules. My name is Els, and I will be moderating this webinar in the background. You will see that on the next slide, please, Thierry. In the background. So that means that you probably already noticed that you're all muted. We are almost 200 persons connected this afternoon. So it is important that you follow a bit the housekeeping rules and bear in mind that you're muted, but you can use the Q&A panel of this Zoom webinar to submit your questions. So please do so by directing your drone to that small window where you can enter your questions. So the aim is that you try to redirect your questions to the speakers. Please do that via the Q&A, not via the chat box, because these messages will not be looked after. You can also upvote on questions, so you can decide this or mention that you think that question is interesting and that the speakers have an idea of the interest to the answer to the questions. Please keep your questions short and concise and address it to the speaker if possible. I also would like to invite you to connect to Twitter should you have an account, because we are on Twitter with the handle @standards4EU, and we often use the hashtag training for standards when it considers our webinars or trainings. So please go to the next slide, Thierry, because we have a quite tight agenda this afternoon. I invite our both workshop chairpersons, Thierry and Christophe, to continue and go through the agenda. Thanks a lot.
Yes, thank you, Els, for this logistics, for the whole logistics support for this workshop. I'm Thierry Legrand. I'm the account manager for mobility in the SEN Management Center, and I will be co-chairing this workshop with Christophe Mazel, well-known convener of D5 Working Group 8 of ASD STAN. So as mentioned, it is a SEN-ASD STAN workshop. Before we start the welcoming, I would like, just while we are maybe awaiting still a few people joining, to give a recap of what will be the menu of this afternoon. So after a short welcoming and opening, we will have a first part. I can say that the workshop is split in three parts. The first part will be more on the legislative aspect. We will have the Commission and EASA referring to the speaking, as well as a short introduction of the work carried out under the work of M567 by Karim Benmezian. After that, we will have a technical presentation of the standard we are considering during this workshop, the PREN 4709-02. And very interesting, it is the first time I'm running a workshop like this one. We will have in the third part really hands-on application. So we will invite a few experts to present their application they have developed and also present some products. So as I said, I introduced already myself, so I will carry on with the welcoming. So SEN and SENELEC are based in Brussels. ETSI is a third European standardization organization. So there is only 3 European standardization organizations in Europe. And of course, we are mirroring global organizations. We are a member-based organization. SEN and SENELEC are driven by a unique support, SEN-SENELEC Management Center, but our members are the national standardization bodies. So the European standardization, the European Standardization Organization are really an effective co-regulation tool. But nevertheless, there is an importance to keep a kind of consensus within each of the countries, so that the system is very well mirroring the organization of the European Union, as we have the national delegation principle as a basis. So our standards are normally voluntary standards. It happens sometimes that they are connected to legislation, referred in legislation, but usually they are voluntary. This is a list of our members. I will not mention all of that. You can have a look and Google and you will find more. And as I said, we are co-organizing this workshop with ASD STAN. ASD STAN has an historic specific status within the SEN system. It is the unique organization who has an associated body status. What it means is that there is a kind of independence of the aeronautical sector to develop standards, and we are sharing the numbers and we are sharing the procedure, etc. Of course, again, we do not have too much time to spend time on presenting ASD STAN. You can Google and find more information on the net. I will let you dig in on that, but ASD STAN is covering much more than drones. There are 10 areas, and they develop standards for aeronautical area. I will also skip very fast to the mission of SEN-SENELEC. I think it has already been quite well understood that we are supporting European legislation and we are also supporting the European economy, and we are really with our values, we are really improving the efficiency of the industrial framework, involving consumers and other actors, and really ensuring quality and safety of products and service, which is again the topic of today. So in the context of the present webinar, we are of course covering this related to the mandate M567, which other colleagues will present later. This is the text of the mandate, but of course, today we will not cover all the subject. The subject of this topic, of this workshop, is very focused on the part 2, direct remote identification. So before starting the presentation, I'm happy to show you a little digest of what we will consider today during the workshop. Note that today we will cover direct remote identification and not network remote identification as it is presented in this video. So we now have to start with a serious business, and so I have the pleasure to welcome in this webinar Jean-Pierre Lenz, with whom we have worked already since 3 years in the preparation of the mandate, negotiation of the mandate M567. So Jean-Pierre can briefly introduce himself and present his slides. I will maneuver the slides as foreseen during the whole workshop.
Thank you, Thierry, for this kind introduction. Indeed, so I'm working at the European Commission, DG Defense and Space, and following the development of the drone regulatory framework. Good afternoon, everybody. To introduce this workshop, I would like to recall perhaps why the European Commission imposed that drones placed on the European market are equipped with direct remote identification function. This would allow to frame the discussion, I believe. When the Commission began 10 years ago to take an interest in the emerging drone technology, it did not limit itself to consider the related safety risks, but adopted a holistic approach encompassing all the potential issues raised by it. At that time, public acceptance was unclear and probably to a certain extent still is today, with privacy ranking on the top of the list of concerns. 6 years ago, security risks emerged as well. First, there were a series of overflights of sensitive sites like nuclear power plant. Then an increasing number of drone incursions into various airports that culminated with the shutdown of Gatwick Airport for 2 days, cancellation of hundreds of flights, and about 400,000 passengers affected by this event. The agility of drones and the difficulty of spotting them and locate their pilot makes drones particularly critical in terms of security, privacy, and data protection. The DRI requirement is part of the Commission response to this privacy and security risk. It will make the drone visible by broadcasting the position of the drone and its pilot. It will also make the drone's number plate readable to ensure that the accountability of the drone operator and reduce reckless use of drones. In addition, the DRI will be a powerful tool to support law enforcement and hence contribute indirectly to safety as well. On its side, the network remote identification function is a safety critical function aiming at connecting the drone to the U-Space service. DRI and NRI are not equivalent, but they are complementary. DRI is requested in most drones operating below 120 meters, because low altitude operation entail the highest risks in terms of security and privacy. Furthermore, drones can be operated without authorization, must have the function embedded in the drone itself. There are, however, a few exceptions. C0 drones are exempt due to the low cost and limited performance of these drones. However, we can see today some drones in this category can pose real privacy and security risk. The regulation defines only minimum requirements. Manufacturers are therefore encouraged to equip their C0 drones with a DRI function if they deem it necessary to prevent their product from being used in a reckless or criminal manner. C4 drones are also exempted because they are model aircraft. However, member states can mandate the DRI on these drones using the zones. In this case, the function can be implemented using an add-on. Drones designed for use in the specific category are exempt when equipped with an NRI function. However, the two functions, as already mentioned, are not equivalent. For instance, a drone equipped with an NRI function only will not be detectable outside the use space. Here again, manufacturers can decide to equip their drone with both functions. Finally, certified drones are also currently exempted. Next, please. Yeah, next, Thierry, please. In consequence, most drones flying at low altitude will be easily identifiable. This possibility should be broadly exploited. Let's now have a look on how DRI can be used to support law enforcement, security, and privacy. Let's start with law enforcement. The DRI requirement ensures that drones broadcast their position as soon as they take off. Officers in the field can therefore detect any drone flying nearby. This can be done anywhere, anytime, including in non-use space airspace. Officers only need to be equipped with a simple mobile device with the appropriate application. They do not need to rely on intermediaries like use-space service provider, nor do they need to request authorization to access drone traffic management information. By providing the operator's registration number, the drone position, and a timestamp, the DRI will enable officers to draw up reports. The connection to the registration database will then enable officers to identify offenders and eventually issue fines. However, this can be done later. In consequence, there is no need for officers in the field to be connected to a network. The possibility to locate the pilot due to broadcast of its position is another means to identify the pilot, which can be quite useful in many cases. It will enable, for instance, the police to quickly stop forbidden operation close to airport. The DRI function provides a powerful tool to support an effective and easy enforcement of the regulation. It will therefore strongly contribute to raise pilot responsible behavior and operators accountability. Next, please. The DRI function will also bring a useful contribution to security mission and the protection of sensitive areas by supporting the analysis of the threat and the decision process. Security forces should be equipped with a computer connected to the registration database. The computer should be equipped with dedicated antennas to ensure the reception of the DRI signal on the broadest possible range. Standalone antennas could also be deployed around the area to maximize the reception capacity. The DRI signal emitted by approaching drones will enable security forces to precisely identify the position and route of the drone and obtain information on the drone's operator. In case member states request in addition registration of the drone itself, the broadcast of its serial number will also enable them to access information on the drone itself. Combined with drone detection devices, this information will help the security forces to inform their decision and define the appropriate reaction. In particular, the detection of a drone not emitting a DRI signal may be considered as a particular threat. The DRI function enables security forces to operate autonomously without the need to rely on intermediaries or request authorization to access drone traffic management information. This is particularly useful in case of covert operation. In addition, the DRI constitutes a balance measure. Security forces monitor drones operation only close to the area to protect. In many member states, it may not be acceptable to grant them the possibility of monitoring all drones operated by all operators over a large portion of the territory. The existence of the DRI function on all drones that can be easily purchased anonymously online or in retail shop will also significantly reduce the possibility of malicious use of these drones, as criminals will have to disable the DRI function first. If the DRI function will obviously not make the criminal use of drone impossible, it will, however, make it more difficult. Finally, the DRI function may also help protecting private properties from burglars who use drones to survey residential area. Dedicated devices could be developed to that end. And now, last but not least, privacy. The DRI function will provide the general public with a powerful tool to address privacy risk and will strongly contribute to reduce public distrust of drones. Generally, people don't like to be observed, especially when they do not know who is watching. Protection of private life and personal data are fundamental rights enshrined by the European Charter of Fundamental Rights. It is therefore not just about public being curious about drone operation. Privacy can easily be violated when operating a drone not carefully. People can feel observed even the drone is not equipped with a camera. Furthermore, personal data could be recorded unintentionally, especially during professional operation. In such case, however, the General Data Protection Regulation will apply. The DRI function is designed in such a way that information broadcasted is readable on most common mobile phones equipped with the appropriate app. Specific devices could also become available. Any citizen will be able to capture the registration number of any drone flying nearby. This will enable the public to enforce their right and strongly contribute to the careful use of drones. The possibility to identify the pilot through the broadcast of his position is probably an even more powerful tool. Indeed, privacy breach are unlikely to be at the top of the law enforcement priorities, and many problems can be solved directly by a dialogue with the drone pilot. Drones not equipped with DRI will quickly become those creating most concerns. The DRI is a balanced solution here again to address the privacy risk to which drone operation expose the public, while respecting the rights of the pilot and the operator. Indeed, the DRI gives access to the registration number and pilot's position only to those people standing close to the drone operation and therefore potentially affected by it. On the contrary, network access to this data in the manner of a flight radar website could constitute a disproportionate solution. Finally, I would like to draw the attention of drones operators to a possibility offered by the DRI function to support their obligation under the General Data Protection Regulation when it applies. The DRI function provides an empty field that can be used by the operator to broadcast the information they need to make available to comply with the transparency requirement of the GDPR. For instance, they could use this field to broadcast the address of a website, providing their identity and contact detail of the drone operation and all the other information requested by the regulation. This is a better way to make this information available their drone to be equipped with the DRI function defined by this standard. Thank you very much.
Thank you, Jean-Pierre. And we may shift swiftly to the next speaker, Antonio Marchetto, who has been still the member of the team having developed the regulation on the open category drone, C0, C4, and also C5, C6. So I will let Antonio introduce briefly himself and make his presentation. Antonio, the floor is yours.
Thank you, Thierry. Antonio Marchetto, I'm a UAS technology expert and the certification director at EASA, and yes, I am still involved in the regulation, in drone regulation, as I have been in the last 5 years. In our drone regulation, we address in general several kinds of risk and that you see listed there: safety, security, privacy, environment. And as you have heard, Jean-Pierre has in particular underlined security and privacy regarding DRI in the previous presentation. Now, how do we cater for this risk? We have a mix. Can you stay on the slide, on the previous slide? Thank you. We provide in particular, and we're talking here of the open category of drones, we provide a mix of operational requirements, pilot competencies, and technical requirement of the UAS. So the regulation for the open category caters for all those risks with the appropriate mix of operational requirements, pilot competencies, and technical requirements. Now, speaking about the direct remote identification, we are speaking, in fact, of a technical requirements. And the next slides, thank you for switching, in fact, is an overview of a broad overview of the technical requirement, which are defined in the Delegated Act of Regulation, Regulation 945, 2019. And these technical requirements can be traced to different kind of risk. You see on the left, you see safety, and in particular ground risk, air risk, but even mixed ground and air, or security and privacy. Now, to give some example, we have a requirement about the maximum takeoff mass or maximum transmitted energy, which depends on the class of the unmanned aircraft in the open category. You know that we have 5 classes, and depending on the class, there is a maximum takeoff mass defined. This is particularly linked to the ground risk, of course. And then we have a requirement for being designed and constructed to minimize injury to people. Again, ground risk. A low speed mode, which limits C2, the class 2, which gets near to people, can get quite near to people, and can weigh up to 4 kilograms. With if there is a speed limiter up to which limits to 3 meters per second. Again, ground risk. Then if you look, for example, if you go down, you look at the controllability requirement. We have a requirement for safe controllability. This can be linked to both ground and air risk, of course, as well as a requirement about the recovery of the C2 link or the flight termination when you cannot recover the C2 link. And the geo awareness as well can be traced to both ground and the air risk. Then a requirement like speed, a system limiting the height above the surface, of course, is very much linked with air risk. If we come to the direct remote identification, we see that it is very much linked to security and privacy. And finally, of course, we have a requirement linked to the environment, noise in particular, but not only. So if we go to the next slide, we looked in particular, in fact, the direct remote identification requirement. This is an extract on the left of the Delegated Regulation 2019-945, which I already mentioned. And it is the extract which reports, in fact, the direct remote identification requirements. And I will not go through all of the points of the technical requirements. You see on the left that it competes to classes 1, 2, 3, 5, and 6 of drones. But in particular, I will point out that the first point, the A, addresses the operator registration number and how it is uploaded in the drone. And the second part, B, lists what are the parameters, data that are in real time transmitted by the direct remote identification system on board the unmanned aircraft. In particular, for the operator registration number, in the regulation, there is an example which are reported on the right. And you see it is made up First of all, of a code, an ISO code, which identifies the state where the operator is registered, in this case, Finland, in the example. Then there are 12 randomly generated characters. So when the operator applies for registration at the member states releases these 12 characters. You see the example there. And then finally, that 8 at the end is a checksum. But this checksum is also calculated on the base not only of the 12 characters, but also of 3 randomly generated secret characters, which are provided to the operators and uploaded. So to calculate the checksum also on the base of the secret characters, but what is transmitted by the drone is only the registration number without the secret numbers. As you see in point B1, the UAS operator registration number is transmitted and the verification code, meaning the checksum. And other parameter, unique serial number of the unmanned aircraft, the timestamp when this has been generated, geographical position of the unmanned aircraft, its height above the surface, the route course, and the geographical position of the remote pilots, when not available, the takeoff points of the unmanned aircraft, and in case, the emergency status of the unmanned aircraft. The final requirements regard the point C, which addresses the tempering of the possibility of temporary functionality and says that this possibility must be reduced, is really referred to the drone itself. And the remote, the reducing the capability to temper the direct remote identification with X on the drone itself. And this would conclude my presentation.
Thank you very much, Antonio, for this good summary of what is the technique and what is the legislation behind the subject of today. We still have a couple of minutes to address in a few words what we are doing within the mandate. And to do this, we have with us Karim Ben-Meziane, who is the technical director of BNIA, and is also the secretary of the working group developing the UAS open category. So please, Karim, the floor is yours.
Thank you, Thierry. Good afternoon, everyone. So I'm here to say a few words regarding the framework, the conformity assessment framework that has been chosen for the open category of unmanned aircraft systems. One thing to notice as the first item is that this conformity assessment framework is based on CE marking, which is a European tool that is a declaration-based, I would say, marking that will allow the manufacturers in order to put their product on the market. And this European, I would say, this CE marking relies on harmonized standard. On the slide, you will see that there is a mechanism that is used by the European Commission in order to request the European standardization system to develop such harmonized standards. And this is called standardization mandate. And the standardization mandate that deals with the open category of UAS is the M5C7. And really, the aim of the harmonized standard is to provide the way that the manufacturer will conform to the regulation. In our case, it will be the part 6 of the annex of the delegated regulation 2019-945. As for this is the part that is dedicated to the direct remote identification. And yeah, this will be the main objective of the harmonized standard, is to provide what is called the presumption of conformity, which means that if the manufacturer applies the standard, then there will be an assumption that is compliant with the regulation. In a more general, in a more broader perspective, you will see that the standardization mandate requests Sensenelec to develop actually 4 European standards, 4 harmonized European standards. You have them on the screen, part 1 to part 4, that are dedicated, if you go for the part 2 on direct remote ID. Part 3 is related to geo-awareness requirements. Part 4 is related to lightning requirements. And part 1 will cover everything else that is covered by the delegated regulation. For instance, it will cover requirements such as maximum takeoff mass, electrical properties, controllability, etc. So this is the set of standards, of harmonized European standards that will support the industry in order to conform to the delegated regulation that has been developed by the European Commission and EASA. I think that's all from Thierry, back to you.
Okay, thank you very much, Karim. So we will shift rapidly to the next session. So the next session, as I said, it is a little bit more technical session, and to introduce the concept, this will be done by Christophe Mazel. And then there will be a presentation of the standard itself, or the draft standard itself, carried out together with Christophe Mazel and Lionel Claris. Lionel Claris being the subgroup leader, is working in Thales. So I'll let immediately Christophe start with his presentation.
Thank you, Thierry, and good afternoon to all. Thank you for your participation to this webinar, this highly informative webinar on the direct remote identification for drone. Now I will introduce, as Thierry said, the main concept who drove this. So as this time, UAS work group to develop this standard concerning the requirement for the remote identification for drone. It's just to highlight the point. So our work was based on a work group composed by experts, but coming from the industry. So the standard is coming from the industry, and the aim is to support all the manufacturers and all the developers who would like to in the future to mark their drone and to address the European market. Of course, our objective was to give all the guidelines and the technical ref for to develop this this DRI function. And of course, the challenge here is to address correctly and to make comfortable and happy all the authorities and also the public, because we are all looking at the acceptance for the future of all the drone activity as a professional we are. So the main concept to develop this standard was, of course, to address correctly who is concerned. So it's all the UAS operators. So meaning that we are talking here about entities. It should be one remote pilot for unique people activity, but also a team of remote pilot, of course, if we are considering the company itself. What we have to, what is the function is to broadcast information. So we are broadcasting identification. So it's the operator registration number. So the operator identification, the serial number of the drone, but also all the flight data. So as it was introduced before, position, route course, speed, pilot location, if it's possible, and also custom data as optional information, which could be, for example, the name of the company or the purpose of the activity. But here is not the mandatory information. To do that, what is needed? We have to have all the equipment on board, so on the drone. So it's addressing a piece of hardware and software to broadcast this information, to collect the data on board and to broadcast the information. And we need on the ground, because we are looking to direct information. So on the ground, we have to consider a receiver, and particularly we are looking for mobile device, which of course everybody is thinking about smartphone, which is the common way to proceed. And if we want to receive some information on remotely approach, so smartphone is very convenient because we have all the features to receive information through the different type of protocol and technology. Here we are thinking about, of course, Wi-Fi and Bluetooth, as it was identified for the function, the DRI function. Who is handling this type of smartphone or this type of mobile device? First category, it's the general public. We are addressing the privacy concern with the DRI. So general public is everybody, as me and the others. We have our smartphone. We are expecting to have the apps installed on this smartphone and starting to listen what the drone are broadcasting. So the identification and the flight data, as I explained. But also the other category is the authorities, which could be Unmanned security or law enforcement. This category of people will have the interest to listen to the drone and also have a cross-ref approach with the identification to know if the operation is authorized and legal. Next slide, please, Steven. By this slide, I will introduce a global picture for what the DRI, how the DRI function was handled in the standard. So you will have a look on the diagram on the right, and reading it from the upper right up to the bottom left, we will go through the full, let's say, scenario of usage for the DRI. First step, the US operator, which could be the company who is willing to operate in Europe, so in the different state members. First of all, we'll have to register with his national authority on the specific service, which will be available and already available for some of our countries. After this registration step, he will receive back an OPRN, sorry, so I mean the operator registration number. This number, as it was introduced before, will after that will have to be uploaded on the UA, on the drone, on the third step, and it will be uploaded on the drone on a different way. So the process will be secured, and it will be on the airborne system itself. Everything is already embedded in the system, or on an add-on if the airborne system is not DRI capability embedded. As soon as this process is validated and confirmed, the drone can be used and fly. And as soon as it will take off, the broadcast of the data has to start. This step happen, and after the starting of the broadcasting, of course, the remote pilot using his own smartphone or observers belonging to the operation will have the possibility to check if everything is fine. So using any any of the technology, Wi-Fi or Bluetooth, he will be able to, with a suitable apps installed on his smartphone, he will be able to check if everything is fine. So the data, the ID, but also the flight information. Of course, what will happen if the authority is in this area and wants to have a look on what's happened on this drone operation, or to check if everything is fine? Of course, he will receive this type of information too, so the identification, but also the flight data. You will have a possibility to cross-ref and check directly on the national authority database through his own server, so entering on the specific website, we guess, and going through the backbone up to the registration database, have the possibility to check if everything is fine and legal again, and authorized for the type of operation, the area of operation, and so on. Next slide, please. So, considering all these concepts, what we introduce in our standards, so what we call the preliminary European norm for DRI, so the 4709 part 2, we present all this information, so the concept itself. So you will find the different section to describe the DRI function. But we have to keep in mind that we are here addressing only the on-board transmitter only part. The receiver's part is, of course, can refer to the standard, but we don't have any standard for the receiver part. It's open to any body to develop, to set up their own apps, their own devices, and we know that this world is moving quickly, and the evolution of the smartphone technology and smartphone equipment is fast, and we are betting that this part will get into next evolution and next performances level shortly. Okay, sorry, Thierry, just to get back on the slide, I will just say that a few words about the general design requirements. You will find all the concept I will introduce, but also specific consideration about the upload of the registration number, but also the security concern about how to handle the tampering part, essentially. And the two other sections are dedicated to the techniques. So the technical solution will be described, either the message structure, the data model, let's say, but also the protocol and also the technology base to broadcast the information. And the last section, and not less, of course, we introduce all the verification and test method to prove the conformity of the different development. Of course, this part is very interesting for the manufacturers and the notified body to prepare their test environment and to be sure that they will be able to confirm the conformity. That's it for me, and I leave the floor to Lionel about the detailed description of the content of the standard.
Okay, thank you, Christophe. Okay, so there are a lot of information in the slides. I will not detail everything. The presentation will be made available after the webinar, so you will have the opportunity to look more into details, and you will have the contacts after this webinar to get additional information you may require. Okay, so The technical standard is here to provide compliance with the regulation, as it has been explained before. So the regulation asks for a certain number of mandatory information. So the technical standard has developed technical specifications to encode the data and to transmit the data from the UA to the external observers. So the operator ID, the basic ID, the location of the drone and the location of the remote pilot or the takeoff location, and the free text self-ID item that was described before. So due to technology limitation of Bluetooth 4, the payload data has been limited to a short length of 25 bytes. The other technologies allow longer messages. So to make the transmission more efficient, an additional class of messages called the message pack type has also been specified to allow transmitted all the information into a single message on the more recent Bluetooth 5 Wi-Fi neighbor addressing network and Wi-Fi beacon that support longer payloads. Next slide, please. So the transmission protocols are the three I have just mentioned before, or the four. If you take Bluetooth 4 Legacy and Bluetooth 5, the Wi-Fi neighbor awareness network allows to discover the neighbors and to transmit directly without infrastructure. And the Wi-Fi beacon is a technology that allows to send information on the location of a Wi-Fi transmitter to allow other receivers around to discover the network. So these technology features are used to transmit the messages, and the way they are transmitted depends, and especially the transmit power, depends on the regulation and the maximum allowed transmit powers for those technologies, which are regulated, as most of you probably know. And the expected range of each technology depends on this transmit power and the type of coding and modulation of each standard. And in average, we can expect from 250, 500 meters for the Bluetooth 4 and up to 2 kilometers for Wi-Fi, Bluetooth 5 being in the range of 1 kilometer. As it was said, the technology is quite common and allows to be received by any kind of receiver. Mobile devices, smartphones are able to receive this information. Also, there are some specificity depending on Android and iOS. I will not go into these details now, but keep in mind that obviously it's easier on Android, which is more open. There are more difficulties on iOS, which is mainly compatible with Bluetooth so far. What is interesting is that we have provided with the standard, you will see that we have a list of tested devices that are known and being compatible with the different technologies. Next slide, please. So, as I saw in many questions that were raised, the European standard comes after some already existing standards, ASTM, which was developed in 2019 in US. In Europe, France has produced its own regulation also in 2019. So the ISD standard was developed in 2019 and was finalized in 2020. So we had this in mind that we should make a technical standard that provide compatibility with the existing standard. So this was achieved by defining a data dictionary that is compatible with the other existing standards, and by making sure the transmission technologies that are defined in the different standards are also covered by the EU standards. And we also added more features in the European standards to perfectly fit with the EU regulation. So on the next slide, you will see a table that provides a comparison of the known standards we had in our hands when preparing the current PREN 4709-02. And this shows how we tried to cover each mandatory requirement for the existing standard with a requirement in the European standard to ensure this interoperability and to allow possibly an easy upgrade of existing devices or solutions into the new standard by a software upgrade as far as it is possible. So this provides an upgrade path that is relatively accessible for the industry and for the operators. Regarding performance requirements, I'll be quite quick on this one. As I already explained, the output power is regulated. It was difficult in the standard to impose any achievable range. From this point of view, it matches what is allowed by the regulation. Obviously, the transmission should be omnidirectional to allow detection by anyone in the vicinity of the UAS. Or of the UA, sorry, the drone, to make it simple. And the transmission rate is 1 second or 3 seconds, depending on the type of data. Whether it's dynamic, then it should be transmitted every 1 second. If it's static, it's only each 3 seconds. That's about the performance requirement. There are not so many in the standard. What is important to keep in mind is that for the integration on drones, you have two possibilities. The built-in solution for existing drones where the transmission technology is already available and where I would say software upgrade is possible that provides a readily available solution. For other drones where the transmission technology is not present or it is more difficult to upgrade via software, there is a possibility to have an add-on device, a standalone device that embeds its own GNSS and the communication capability to transmit the information. And this is perfectly suited for retrofitting of existing drones, in particular when operating in the specific category. And these add-ons can be seen as building blocks that can be available for drone integrators or manufacturers to easily comply with the regulation without having to develop their own solution. Next slide, please. So there is an important part in the standard, which is the demonstration of compliance. So the regulation has a certain number of requirements. The technical standard provides some technical specification that if you comply, if you implement this specification, provide you compliance with the regulation. And to make it easier for the manufacturer and for any organization that will verify the compatibility or the compliance of your device, there are a number of test methods that are provided in the standard to verify if the information that are transmitted are the ones that are expected, if the protocol and the transmission technology is appropriate, and there are two kinds of verification methods detailed in the standard. Some are based on design file verification, checking that the components that have been selected to implement the wireless technology is compliant with the specification and the regulation. And some are tested via experimentation to verify that the appropriate data are transmitted. This kind of things. So if we go to the next slide, the correct information uploading verification, the accuracy of the data that are transmitted, the transmission rate and the data update rate are typically verified through testing. And in the standard, you have some extract from the standard here. It provides some test setup and some recommendation or indication on the test equipment that should be used to perform the testing and the verification that the implementation is compliant with the standard. And if you are compliant with the standard, hence you are compliant with the regulation. So for the receiver, as we have explained, it is not really fully covered by the standard, even though there are some indication in the standard that the receiver should provide a certain number of features, and there is a significant amount of information available on the GitHub of OpenDroneID to find pieces of software to build the application, and the list of compatible device and the testing methodology is also referenced there to help finding the appropriate devices and get the appropriate application or develop the appropriate application if it is the intention of any developer. I think that's it. It was pretty quick, I'm sorry, but again, we are available to answer your questions after this webinar.
Okay, we receive already a lot of questions through the Q&A, and Christophe, who is co-chairing and having a look on the question, will try to repeat some of the question and try to give a reply, or invite Lionel if he's more competent, or maybe there are some questions also for the Commission. So Christophe, what is the first question? We have about 5 minutes to.
Okay, thank you. So, yes, good comment. In fact, we have received already a lot of questions, and a lot of them are already answered. But we'll go through the most ranking part. So, and getting back to the first part of the presentation, I will ask Jean-Pierre if he can answer to the first question about the way of using an RI versus DRI, so the network remote identification, and versus the direct remote identification. So the first question, please, Jean-Pierre, if you can answer.
Yes, I try to reply already by writing. In fact, else introduce the answer, but I can repeat. So basically, indeed, as I try to indicate in the presentation, we have two very different requirements, one on security and privacy, and the other one on safety, basically integration into the use-based service, which require two technologies in terms of transmission and broadcast connection. The DRI request a broadcast towards mobile device without the need to have an intermediary, while the connection to the use space indeed requests to be connected through the network to the use space service provider. So these are two different requirements that call for different technical solutions. This is why we have the difference, and we are not the only one. If you look at the STM standard, as it was explained, they have also this two dimension of the remote identification for two different purposes. I don't know, Christophe, I can perhaps also quickly
take the second one about the
question.
privacy.
One was about Article 40. There, I would like just to answer that Article 40, I mean, at the Commission EASA, we are eventually looking at this article also now in the framework of the development of the use-based regulation, and we may eventually need to come back to it. By the way, it is indeed not very clear what is requested there. So I would not answer directly to the question, but mainly say that we may have to come back to the article in view also of the use space development. And by the way, the NRI function is by far not define enough probably in the regulation today. So we may have to come back to it again once the use space regulation will be out. And perhaps a more general question about privacy of the pilot. I just want to remind two things. First, drone, operation is a public, operation. If you operate the drone, in the public area, it's like when you drive a car, you are sitting behind you are driving the car and people can see you. But more fundamentally, when we look at privacy, we look first, it's a right for everybody, but first, obviously, for members of the public, which have nothing to do with the drone operation, have just to, be subject to this operation close nearby to them. So they are the first to be, protected in bracket, and the pilot, is the second one, but the pilot is responsible for the operation and may decide, I don't know, not to go for it. So first the public and then the pilot. And this is why, again, as I tried to explain, the DRI is in a way a balanced position, a balanced measure, which limit the access to pilot and operators data really to the people which are affected by the drone operation, and not like, let's say you may have access on a website like Flight Radar, where we have broad information. We believe that by the mere fact that the broadcast is limited, and you mentioned the figures, there will be a difficulty to integrate the data and to bring them together and to cover wide areas. Now, if this never ever happened, then of course we will have to assess the situation and eventually take measures. But I just recall also in my answer, for instance, in Google Street, there were measures taken or others. So, this we cannot assess before having really the situation. But to come back to the question, public versus pilot, I think it's important to understand public first, and the pilot who is responsible for the operation, comes in second. Now, the question of law enforcement, I think it's also rather unrealistic to expect that the police will run each time your neighbor is flying over your garden, and in a way, and that has been shown in studies already. Many of these, let's say, household situation and conflict are better solved directly, and it's only when this is not possible that you would go to the police, really complain. So again, we believe this is, let's say, a balanced approach. Thank you.
Okay, thank you, Jean-Pierre, for the question. The answer to the question, actually addressing the question from Gerald and Torsten also.
Christophe, I think we will stop the question for now. There will be again a possibility after the practical session, after the third session, there will be still room for question if we have time. And anyway, I understood that the working group will reply the question, and we will make it available on the website, let's say by end of February. So in order to keep the time and not to be late, I would like to invite you. It's 3:09 on my watch. I give you 6-minute break, so we will reconvene at 3:15.
Thank you, sir.
So we are back into the workshop, and this part, as announced, will be much more practical, and we will involve a series of experts who have been very active in the development of the standard, and we will be able to show you really some real application. We will present you 3 little videos, and there will be a short demo or short presentation of products or applications. And in order to do this, so you have on the screen all the contributors to this third session, and they will be, of course, able to reply to your question because they are with us. So I think I will now introduce I pass the floor to Lionel so he can start introducing the 3 video and the speaker, and then we will go with the 3 video. Please, Lionel, can you take over?
Yeah, thank you, Thierry. So yes, we will see three video prepared by the working group who worked on developing this standard, and you have seen the people on the previous slide. So the first video will be a focus on the presentation of the introduction of the operator registration number in the device or in the remote ID. With the security feature. So this presentation, you can go next 2 slides, please, Thierry. Yeah, so the next presentation and video will be presented by Jan Brooks from Unifly, who is a company involved in the integration of drones in the airspace and who is developing a remote ID an add-on device for the remote ID. So Jan, I leave the floor to you to introduce the video and the topic.
Okay, thank you. Good afternoon, everybody. So, as it already was explained by Antonio, the registration number of the operator is basically something that each operator will receive from the member state. This operator registration number is a unique number, and in fact, only the operator should know the complete number. So the first 3 characters, as already explained, are the country codes, followed by 12 randomly generated characters, the B characters in the slide. Next to that, we have the 3 D characters, which are basically the secure characters, which only are offered to the operator. And they are used together with the B characters to calculate the checksum by means of a learn algorithm, which is similar to what's used on credit cards today. So going to the next slide. Yeah. So in case that the operator enters, let's say, a wrong registration number, then this checksum will not match, and you will receive a null displayed on the platform, as well as the null being broadcasted. The operator receives so the complete string, but the XYZ component, as detailed in the slide, that part is never transmitted nor stored on the drone or the add-on. That's in order to actually prevent people from starting to go back and do the learn algorithm backwards forwards. Next slide, please. And then in the second stage, there is also the unique serial number, which is following the ANSI format. And this unique serial number is entered at the manufacturing stage, and it cannot be changed afterwards after leaving the factory. So for drones and for add-ons, it's the manufacturer who actually enters this unique serial number. So let's now look at a video on how this initialization process works in real life.
The new European European drone legislation uses Direct Remote ID as a license plate for drones. To operate a drone in the open or specific classes, the owner registers as its operator. A unique operator registration number is issued by the national authorities to upload as operator ID information of the drone or unmanned aircraft. Entering an incorrect number causes null to appear on screen. The license plate is easily attached to the unmanned aircraft. Upon broadcast, authorities can check the information's validity. Once the operator registration number is entered correctly, the drone operator can start his flight via the app. Public observers can only see the unique identification number without any other information on the operator or the unmanned aircraft. The Direct Remote ID add-on meets mandatory EU requirements. It broadcasts a unique serial number, timestamp, and geographical position of the unmanned aircraft. Authorities can access the registration database and use the identification number to refer to the detailed information of the drone operator. In short, Direct Remote ID allows identification of drones for safety, security, and compliance purposes.
Okay, so just to recap, if you can go back to the slide deck. Yeah. So as you saw, there is basically two different stages, whether you enter the operator registration number with a valid registration number, or if you enter it with an invalid, in which case the system refuses to actually accept the registration number. And then in the scanner app will actually display you the operator part, which is publicly available. This scanner app is basically shown in the next videos, which Thomas is highlighting. Thank you.
Thank you. I don't know if Christophe or Lionel got some questions. Otherwise, we can come later.
I think on this topic,
yes. No question?
We have one question about the level of security for to discover the registration number. So probably, Jan, if you want to answer on that, are we protected on the upload mainly than on the broadcast, the topic?
Yeah, the upload, it's through a Bluetooth, in our case, a Bluetooth connection towards the drone. So you need to be within the reach of the drone in order to upload this registration number. Once you're out of reach, then it's no longer possible to change, let's say, the operator registration number. Does that answer the question?
And mainly it was for the to interpret when the registration number is broadcast. We know that it's possible to discover it by intense calculation about how to extract the information. But yes, the topic was mainly we have the requirement to secure the upload of the information into the drone. But of course, after the broadcast, it's not easy. We not make it easy for the people who want to collect the information. But of course, it's not fully cyber security proof. Actually it's not the purpose. But anyway, I think it was a question for Drew mainly. No, and for the other part, I think we can go.
Christophe, I don't know. Christophe, if you allow me, Jean-Pierre Lenz from the Commission, I can perhaps explain the requirement a bit more precisely. Yeah, it may look a bit, weak to use this checksum, learn algorithm. First, please remember DRI is not a safety critical function, and we do not protect the signal emitted against spoofing or any other, let's say, intervention. NRI is a safety critical, and there will be all the security needed in place. Now, the reason why we have this system is only to avoid that your neighbor, if he wants to do something wrong with his drone, is using your own identity, put it in his drone and fly with, your number. It's only for that purpose. We wanted to have even more secure system, but member state would have had to implement, let's say, the same level of safety in the registration and the delivery of the registration number into the drone, and they were not ready, or at least not all were ready to do such. So based on this position of the member states, which were not really ready to implement strong security in the delivery of the registration number, it was decided by EASA to have this, let's say, indeed a bit limited approach, but again, the only purpose is to avoid that your neighbor or anybody could easily use your identity to do something wrong with his drone. Thank you.
Thank you, Jean-Pierre. Lionel, could you introduce the next video and speaker?
Yeah, sure. So the second video will show some samples of integration or implementation of the Direct Remote ID in different kinds of drones and their operation in real time. So this presentation and video will be presented by Thomas Markert, who is working with D-Drone as a US program manager. And D-Drone is a company that's also involved in airspace security. And that's why they elected to contribute to this development of standard. So Thomas, the floor is yours.
Thank you very much, Lionel. Good afternoon, everybody. Yeah, I would like to present you today a short video about the integration of remote ID into the drones and how to operate the DRI. But before I want to show you the video, I would briefly explain you what you're going to see so that it's easier for you to later understand what you see in the video. So as we've seen before, there are basically 4 wireless technologies defined in the standard. And the main purpose of the video is to show the interoperability, so that it's possible to receive all the different wireless technologies with just one smartphone and one application running on the smartphone. So you will see a parallel NAFI with an updated firmware transmitting remote ID via Wi-Fi beacon. There will be a DJI Mavic Air with a modified firmware so that it transmits remote ID using Wi-Fi NAND technology. And there's going to be a DJI Mavic 2 that we equip with an add-on device from Drone Tech, which transmits Bluetooth 4 and 5. Yeah, there will be one receiver. It's an Samsung Galaxy S10 Plus smartphone where we run the D-Drone drone scanner application on. The smartphone as well as the application, they support all of the mentioned wireless standards. And in the default view of the application, you will see a map view. And on this map view, you're going to see the drone position as a yellow diamond, the pilot position as a yellow triangle with a dot, and the position of the smartphone. And the drone, or each drone, will be labeled then with its UAS ID, in this case, the serial number. I think that's enough of preparations. So please play the video. We'll come back, or I will come back to you later then. you very much. Yeah, so yeah, the video was quite quick and there was a lot of information. That's why I want to just quickly come back to the info screen of the app, where you can basically see all data that is transmitted via remote ID. So apart from some wireless communication details, you find all data of the drone position, speed, and the accuracy of the data transmitted. You can find the location details of the pilot, as well as the category of the drone and the class. You can also see a custom message, for example, the flight purpose that can be set by the operator, as well as the ID of the operator. Next slide, please. Yeah, just a short summary. Basically, what we have seen in the video is that it's simply enough to have just one smartphone running one application to observe multiple drones in your vicinity simultaneously. And it's also enough to just one smartphone, one application to receive all of those different wireless technologies defined in the standard. Yeah, that's it from my side. Happy to take your questions if there are.
Christophe, do we have question on this video?
I think we have one question for Thomas. I think it's one question from Thomas Oster. So regarding the problem related to overlapping replies when too many drones fly at the same time. So I guess it's what you demonstrate.
Sorry, can you please repeat it?
Okay, if you have the question in front of you, but I will read it for this. Is there a problem related to overlapping replies when too many drones fly at the same time?
So I understood it's if there are multiple drones operated, if we see some interference basically, and I mean, in theory, of course, there is. If you have, let's say, hundreds or many dozens of drones, there will be at some point some interference reducing the performance. That's for sure. But we haven't. So we tested with up to 5 drones, and we haven't seen any issues there. And we also tested this not only, as you've seen in the video, in the field, but we also tested this in urban and industrial environment, where there is a lot of wireless and other traffic present with a lot of interference, and still we got reasonable performance out of it. I hope this answers the question.
Okay, thank you. We proceed with another question, Thierry?
Yeah, yes,
Okay.
if you have a last one, and then we go and we come back later, but a last one.
Okay, so probably it's a question regarding the Wi-Fi beacon, especially, but probably it's not Thomas who will answer, but Marine. Regarding the Wi-Fi beacon scanning, sorry, it's jumping. Changing the Wi-Fi beacon scanning rate will have a detrimental impact on phone for the use. Do you have any feedback or return of experience on that? It's a question from Robert.
So the only negative impact that I'm aware of is very, very little could reduce basically your battery time of the phone. I mean, obviously it's checking Wi-Fi networks more frequently, your phone, so it uses more battery power. But yeah, I did not notice it, neither did anyone else using the app notice it. So I think it's less than a couple of %. So it's not really noticeable, this impact.
Marine from Parrot?
Yeah, hello everybody. Good afternoon, everybody. So yeah, I mean, for the general public, you know, the most useful information will be the static ones. And so the scanning won't be necessary like all the time, but for instance, for law enforcement, they will have more receiver performance will allow the scanning more with a more refreshing rate improved. But actually, no, we did not really notice any troubles about the scanning.
Okay, thank you.
Okay, let's see if we have still time.
Okay, we can.
We will come back if we still have time. We still have a question and answer session at the end of the workshop.
Yeah.
So please, Lionel, could you introduce the next speaker?
Okay, so the next video will show a long distance operation of the DRI and will be presented by Ronald Libsch from DJI, acting as Technical Standards Manager in Europe. So Ronald.
Yeah. Good afternoon, everyone in the room, and thanks for giving me some minutes to speak about the performance. I already see in the frequent questions some questions about the performance of how far DRI can be received, and that was exactly the purpose why we are presenting you now a video dealing with the performance, the receiver performance of different smartphones. So you can see on the slide that we have conducted some tests using an own receiver app, so not the app we have seen by Dedrone. It's an own receiver app, only receiving the Wi-Fi NAN protocol for internal test purposes. But this has been set up based on the same piece of technology like Dedrone did for the Wi-Fi NAN protocol. And we have conducted some flight tests outside of Europe and China to have also included the proper differences of the impact of interferences, because the expectation, what has been presented to you at the beginning from Christophe, was that the DRI as such, with regardless of what technology, is somewhere in an urban area between 300 meters, 1 kilometer, maybe 2 kilometers. But we really want to conduct some tests of what is the exact range with a common available smartphone. So you will see in the video shortly, just because there will be a lot of information, you will see in the video a flight in a suburban environment over a lake, and a flight in an urban environment with very high skyscrapers. And there we have made a little bit longer video than the others, but I guess that's very good to explain the performance limitations we have pursued. Yeah, please go on with the video. So we start with the suburban environment. We have measured some interferences. We have integrated in our DJI systems an own Wi-Fi working channel measurement tool. So it's started on the bridge. You see the different phones we have evaluated. So S10 Plus, Google Pixel. And there you can see on the video the same information like provided by the Dedrone app on the right. So you have the ID, you have a video screen from what the remote controller sees, and on the left this is the performance. The left is the height, and the other value is the distance from the operator. The video is a little bit speed up to spend the time on this. So it's now nearly close to 3 kilometers. It's a constant height, so it's still in the radial line of sight performance, and the signal can continuously be received. You see the message setups on the left, and now we are coming close to 4 kilometers, and then the packages have more losses. So if you are speaking of a continuous receive rate, we are having measured about 4 kilometers in some of an environment with a constant height, with a constant speed. And then making the same test in an urban environment. So you will see on the video a lot of skyscrapers. The interference measured is a little bit higher. So that could be an operation in an urban environment in the future. Not speaking about the video systems now, but just from with regard to interferences. It's the same thing can be received on the app. So what you see is just the recording of the app screen. You see the flight height is 180 meters. We are now in a distance of 1.25 kilometers. And then we get some interferences because the skyscrapers make some interferences. So the height you will see on the left is now increased to check whether this is then can be received to a farther distance. So we are now in one higher, 230 meters. And then in an urban environment, we were able to detect continuous signal up to 2 kilometers. So there is still a different impact on the performance if you are flying in an urban or suburban environment. And another impact on how to receive the signal is visual obstruction. So if you are with the receiver app behind a building, you will not potentially receive the signal. So it's really important from the receiver side to have visual contact with the drone. Yeah, and that's it. A very short summary of the test. Just give you a brief introduction of what can be done with DRI. So it's just to summarize, it has been tested on 4 common available smartphones. So even with this off-the-shelf technology, you can receive the signal in a 4 kilometer distance in a suburban environment and 2 kilometer distance in an urban environment. If you have a better receiver performance, for example, for the security forces, then the range can be much more enhanced. So we have seen a lot of impacts due to visual obstruction. Interference is a topic which you cannot predict in the beginning. It very much depends on how crowded is the area you are flying, what other devices are interfere your signals. And then it's also what has been seen during the test, that it's a matter also on the receiver specifications. So different smartphone providers are, for example, constructing their antennas in the phone differentially, and then also has an impact on the receiver range performance. But as I said, from a public aspect, this is way over our expectations in the beginning, but for a security force aspect, they can improve the receiver performance enormously when having dedicated equipment, e.g., for example, special antennas or dedicated hardware. Yeah. And if there are any questions, I'm happy to stay here.
Yes, please, Christophe, did we got a question for Ronald?
Yes, we have one question dedicated to this video, so coming from Michael. What's happened with the drone approaching the area? So how long getting out of the range for the broadcast and getting back, how long it will take to get back on the receiver? So if you can grab a look, so probably the question is quite long, so but it's mainly the meaning of the question.
Sorry, I cannot get what you're looking for.
Okay, so then looking at the drone flying away up to 4 kilometers, is there any experience when the device detects an approaching UAS that has not been connected before and needs to start and check the process first? So how long it takes to be taken into account by the receiver?
Yeah, so well, that's maybe more a question to D-Drone or the ones who are developing this app, as it depends on whether you are actively scanning on the different Wi-Fi and Bluetooth channels. So this was not the purpose for this video to demonstrate the passive detection capability. But generally, from our perception, it's not a big deal when you see a drone and you link your receiver to the phone to want to know what this DRI information is about, then the information should be there. But maybe a question for later on for Thomas, if they have observed or did some tests on this.
Can I quickly jump in, or?
Go ahead.
Okay. So as this, all of the remote ID wireless technology is all one directional, it doesn't matter if you fly away or if you approach the receiver. Each packet received is received the same way. It doesn't matter if you received the packet before or not, or a Wi-Fi frame. There's no difference. So it's not that the receiver, for example, expects a drone because 1 second before it received a packet from this drone. It's handled all the time the same way. I hope this answers the question.
Okay, maybe we can elaborate later further. Let's try to move to the next session, which I give back the floor to Lionel to introduce now a series of applications, I think, and I let you present them.
Thank you. Yes, now we have a sequence where the experts you have seen that participated in developing this standard are also industry and are offering products on the market. So now we are facing the necessity to equip the drones with a DRI to operate, at least under the condition where it's applicable. So let's see what's available and how the different set of manufacturers have elected to answer this requirement and support the operators in complying with the regulation. So let's start with Ronald, who's still online.
Yeah. Thank you for this question. So
back Thierry, sorry. Thank you.
Yeah, Lucas is after me. So what we have seen today is a kind of very brief overview of what has been developed on the EU side from within the ASD STAB group. And the main purpose of this standard is to fulfill the needs of the new EU requirements on the C1, C2, and C3 category on the DRI. So for DJI, we are doing this for exactly comply with the regulations, to have the standard together with the other standards to demonstrate compliance to the CE classes. We are constantly follow this approach, but we are still in the drafting stage. So it was said at the beginning that this is a draft now. We are expecting the draft to be voted very soon, and then we have to resolve all the comments. And once we have all the maturity that this is the technical solution, this is the standard we are looking for, we will develop the solution in accordance to the standard. So for the time being, I must admit, I cannot say that we are putting DRI on all our drones as you have seen it today, because there's still some way to go to finalize the different details of the standard. But we're working, we are collaborating with the other drone manufacturers, and once we have assurance that existing or upcoming drones can be get a CE class retroactively, then we will open up a list or develop a list of which drones will receive a retroactively CE class label that then has this functionality on board. Or for drones which may not belong to a CE class and have to fulfill the needs of the specific category, we are also in the starting seats to give solutions to our operators, like we have seen in France, where some drones have received a firmware upgrade where it is possible to have to comply with the French regulation on this piece of technology, and other drones may need an add-on which also can be a solution. So definitely there will be a solution for every DJI drone, either by an add-on or through a firmware upgrade, but I must admit we cannot say which drone will have which solution. But on our technology, we are convinced that the Wi-Fi part doesn't have or have the best performance. So that's why we are strongly convinced to deliver a Wi-Fi non-solution, or at least a Wi-Fi beacon solution for the time being in France.
Okay, thanks, Ronald. Now we move on to drone tag and Lucas Borschel, who is founder and managing director of a small company that is developing this product that you will be presenting, Lucas. So go ahead.
Thank you, Lionel. Good afternoon, everyone. I would like to briefly introduce you our solution drone tag mini that we developed in Czech Republic. And I would like to also speak a little bit about our practical experience in implementing the Bluetooth DRI according to the standard. So we already know that the main motivation for the add-on solution is that it fulfills the standard for drones that cannot have the firmware update, and it could be implemented either via Bluetooth or Wi-Fi. So why did our company choose the Bluetooth and how it went? Well, generally speaking, for add-on manufacturers, the implementation of Bluetooth DRI is much easier. The main reason for this is that the current era of smart IoTs, everything has rapidly accelerated Bluetooth chips development. The consequence is that the Bluetooth modules are cheaper, accessible, and they have greater software support. To name some particular advantages, the open source library Open Drone ID provides plug-and-play solution for any Bluetooth module. And from the observer's point of view, all current phones support Bluetooth 4 legacy, and almost all new phones already support Bluetooth 5 long range. At the moment, the support of the Wi-Fi DRI is more unclear than a Bluetooth. On the other hand, the common limitation of Bluetooth chips is that without any modification, they come from the factory with low TX power, which for your imagination could be even 40 times less than in Wi-Fi case. Therefore, the range is generally smaller. So what we have been able to implement in our case, we created a tiny independent IoT device that supports Direct Remote ID, but also the network ID for the upcoming use cases. We support transmitting both Bluetooth 5 and Bluetooth 4 messages at the same time, and also at the configurable frequencies. The device has its own GNSS receiver, battery, and also internal antennas. And it all comes in a 30-gram matchbox size device that can retrofit almost any existing drone. So how do we try to differentiate from the other manufacturers? Well, the main thing is that the Mini contains a power amplifier to extend the DRI range as further as possible. So we have achieved 500 meters in urban areas and over 1 kilometer in a countryside with a mobile phone as a receiver. If the user needs to go even further, they can equip the device with external Bluetooth antennas to boost the range. We are developing something that we call open interface, allowing you to access the data from the flight controllers, such as a DJI or Pixhawk. Our device will be available for buying in Q2 this year, and it will come with iOS and Android management app that will also show you the airspace overview. And thanks for your attention. Please feel free to ask any questions regarding to Bluetooth DRIs. We will be happy to help.
Thank you, Lucas, for this interesting feedback and return on your experience on how to implement Bluetooth DRI. Now we have another approach from Pierre-Alain Marchand from SenseFly, drone manufacturer in Switzerland. So Pierre-Alain, tell us about your implementation of DRI.
Yeah, sure. Well, good afternoon, everyone. On our side, well, we decided to choose the Wi-Fi non-aware protocol, and I'll try to explain briefly why we did this choice. So first, our EBX is equipped from a proprietary radio module. So we basically started from nothing. We didn't already use Wi-Fi or Bluetooth for the C2 link. Then we think, well, we had the feeling that it was easier to find a Wi-Fi aware module on the market compared to Bluetooth 5 long-range ones. And from a software point of view, I think Wi-Fi is as easy as Bluetooth to implement. But in the future, we think that we could use Wi-Fi for other purposes, like transferring picture or upgrading the drone, etc. That's why we chose Wi-Fi. And as it has been said in the presentation before, Wi-Fi NAN is one of the technologies which has been also chosen by the ASTM for the US standard. So on our side, it was better for us to choose this one also. And during our tests, last point is that we managed to achieve a good range with a dedicated receiver on the ground. So maybe you can move to the next slide. So, well, just briefly, so Sensefly is part of a powered group. We are 100 of people based in Switzerland, close to Lausanne. We are focusing on light, compact, easy to transport, and robust fixed wing for professional. Our last release drones are the EBX and the EBGO that you can see on the slide right now. And well, in a few weeks, all our drones that will be shipped to Europe will be equipped with DRI based on Wi-Fi aware. So that's it for me.
Thank you, Pierre-Alain. Very good. Now we have Jan Brooks from Unifly, company involved in aircraft and drone integration and airspace security. And they are also developing solutions for DRI. So, Jan.
Good afternoon again. So Unifly basically decided to develop our blip, as we call it. It's a combination of both e-identification and tracking. It has, let's say, syncs to multiple GNSS constellations, and it also interfaces with the Unifly unmanned traffic management platform using, let's say, GSM, the LTE network. The product, let's say, is rather, let's say, cheap for drone users compared to the existing maybe ADS-B or FLARM devices which are on the market. The product is also compliant with both standards, so both ASTM and as well as the European legislation. And the product is CE certified as well as FCC certified today. So it's a product which has been used already for at least 1 year in different European projects to provide situational awareness to basically authorities to identify where drones are flying. I think the most known one is the Sapphire project, where the blip was used to offer a positioning of all the drones flying in the Sapphire project to the international airport airspace. The authorities which were managing, let's say, the combination of both drones and manned aircraft. Next slide, please. So it's a combination, it's a totally standalone product. Everything is embedded. We use Bluetooth 4. It's connected via the LTE towards our platform. So it's a combination of both the direct remote ID as well as the network remote ID tracking. And it has also a barometric altimeter embedded to actually match barometric altitudes to the authorities who want to compare it with civil aviation, also using barometric altitudes. As you can see on the picture, it's controlled by a remote app, and it has been used in several demonstrations. The one which you saw here is the volocopter flight in Singapore last year. Thank you.
Thank you, Jan. Okay, so now another approach from Parrot drones that will be presented by Marine Balit and their roadmap and choices to implement the DRI. Marine.
Okay, well, thank you, Lionel. Hello again. So you can move on the next slide if you want. Thank you. So Parrot Drone, as a French drone manufacturer, has been involved for more than a year now in the new European regulation, and especially on the DRI standardization. Parrot has been designing and developing civil drones for more than 10 years, and Wi-Fi-based products since even before. Because of this experience on Wi-Fi, we decided to integrate the DRI message in existing technology called Wi-Fi beacon. So first, how does Wi-Fi beacon DRI technology work? Parrot drone's control link is based on standard Wi-Fi technology. The drone is acting as an access point and sends beacon packets by default for its command and control link. And as you can see on the snapshot example, the Wi-Fi network of an Anafi drone is visible on a smartphone. How our engineers implemented the function, actually the DRI data has been embedded within the already broadcasting beacon frames. So Parrot thinks that a Wi-Fi beacon is an easy, cheap and standard solution for broadcast remote ID. First of all, for a Wi-Fi capable drone, Wi-Fi beacon remote ID does not require broadcasting any new packets, only adding additional information to already broadcasted packets. The solution is easy to implement. And then any Wi-Fi capable phone or laptop has the ability to detect and extract the relevant information from a beacon. Therefore, Wi-Fi beacon massively increases the number of smartphones capable of efficiently receiving the remote ID message element. The solution is universal. And this solution is also cost effective. In fact, as said previously, the Wi-Fi technology is already known. No major software development is needed. And to finish, since the broadcasting channel is not fixed, drones can optimize their operation by selecting an optimal channel. This will minimize RF channel congestion and thus improve direct remote ID performances, especially when several drones are flying at the same time. And you can move to the last slide. Thank you. So what about the Parrot product roadmaps? The first version of the DRI feature has already been developed and released for the whole Parrot Anafi range, including our new drone Parrot Anafi USA. The ISD 10 version of the DRI standard feature has also been tested and works well as a beta version. In the near future, the user will access it on the preference settings on the Parrot Free Flat 6 application. So this is it for me. Thank you for your attention, and I can now leave the floor.
Thank you, Marine. I think this was very interesting to see this variety of options that are offered. You only have there a few manufacturers that were actively involved in the development of the standard. So this leaves you an idea of how much options you have to comply with the regulation. So Thierry can hand on to the next section.
Yeah, I think I will take this section with Karim. So as already introduced and referred by some of the speakers, the document is currently at inquiry, and the closure of the inquiry will be 25th of February in about 15 days. So you know that the inquiry is during 3 months, so it starts already in December indeed. And the planned publication date of the standard is end of this year, in fact. So Karim, I hope you can confirm this schedule and maybe tell us more about other perspective of the development of the standard?
Yeah, I'll try to be quick. So just because maybe some of the participants are not familiar with the SEN process, the SEN inquiry is a technical consultation that is distributed to all the SEN members, meaning that every national standardization body will receive have received actually the draft. And this will be available until the, like Thierry said, until the 25th of February. We expect to receive some comments, some technical comments on the draft. And after the closure of the inquiry, we will enter a comment resolution period that will involve the ISD STAN D5WG8 working group, and especially the subgroup that deals with DRI. The comment resolution period should last for at most 3 months. That's our plan, so that the document can be updated and processed to the next stage, which should be what is called the formal vote within SEN. So yeah, I can confirm that the current publication objective is the end of the year, like Thierry announced. Back to you, Thierry.
Yeah, I think it's also back to the questions. So Christophe, you are still managing the follow-up of the questions. Maybe
yes.
we have some interesting one. Please go ahead.
Yes, we have some. So do we have the 10 minutes?
Yeah, we have
okay. Thank you. So, so first of all, I will just highlight one answer. This question that the contribution of Paul Alexander on the Q&A panel, because most of the question, of course, can be answered already answered by writing, but also by reading the white paper. So please have a look on the white paper link the link to download the white paper. Probably you will have also many answers in this document. Thank you, Paul, for that. So just going through different questions. So it's a more general, now getting back to the general topic. A question from Edwin for, I think, for Antonio or Jean-Pierre. What is the reasoning behind not making direct remote ID mandatory for specific flights? Jean-Pierre or Antonio?
I cannot hear you very well, Christophe.
Okay, so what is the reasoning behind not making direct remote identification mandatory for specific flights?
Yeah, I mean, I will take it. We need, I mean, Article 40 needs further consideration. Eventually, as I already mentioned, we need to have eventually another look on what we exactly mandate in the specific category, taking into account the use space as well, and how we will also impose the NRI requirement on the use space. So I think we need eventually to come back to that. So today, indeed, I would not say this is the final word. And by the way, this article is unclear. So
Jean-Pierre, I answered to that comment in written.
Yeah, me too. So
okay, it was still pending on. Sorry, I haven't read all the written things.
So I think.
Okay.
Yeah.
Okay, and Jean-Pierre, so actually, because you are on the floor, you have a specific question you wanted to answer directly. So could we have a stop flight option ever for the US?
Yes, yes. I mean, in order for the app to be able to connect you by phone, you would need to have access to the phone number of the operator. This is only possible for authorities which have this access granted. And by the way, in this case would be probably the phone number of the operator, not necessarily the phone number of the pilot operating. But this would be possible for authorities, security, and eventually, as I mentioned, enforcement officer in the field if they are connected live to the database. Now, this would not be possible for the public, because the public citizens will have no access to the registration database. The only way for them to contact the drone pilot would be indeed to walk to the pilot if they are able to locate it with the help of the, let's say, location provided by the DRI, or if they are able to notice who is behind the remote control of the drone. So no stop, let's say, function as such on the application, and no contact apart for the authorities.
Okay, thank you. Actually, it's a mix of different questions and comments on the panel regarding what's happened in France. So I guess we have already answered to some of them by writing, but just to let you know, but for the French people, I think it's obvious, but for the others, so we have the specific law in France already imposing this requirement of DRI, but with a specific way. Just to mention that for the community, we are talking with the French authorities in order to harmonize in the future the DRI function on the UA, on the drone flying in France. So of course it will take some time, and there are many authorities, French authorities are waiting the publication of the harmonized standard, so the level of the document. But yes, of course, it's a double approach. It is not fully compatible right now. We have the same protocol with the Wi-Fi beacon, and but as Lionel explained, so it's not compatible for the message broadcast currently. So yes, the two options are necessary if we are looking currently at the situation. I don't know if somebody wants to add something specific on the French position, but if not, we can follow. I have quite some question that we get back to technical question, and mainly for the ones representing, for the experts representing the manufacturer of add-on. One question about the fact that putting an add-on on top of the drone could impact the downward range of sign-on, or will impact the coefficient of the drone. So for the Lucas or Jan, manufacturer of add-on, what do you think about adding an add-on on the drone? What's happening?
Well, that's something we have encountered in a drone tag, that we saw this, let's say, performance degradation when you put the add-on on top of the drone, because the signal is actually shielded. So that's why we added an option to add an external antenna. But in some cases, you don't have to put the device on top of the drone. There are some drones that can allow you to put on landing gear, for example. So yeah, there is always a way to achieve that. It's just the matter of the drone and the add-on device.
Just confirming what Lucas said. We have the same experience. You put it below, you have better results on the broadcast part.
Okay, thank you. So I think we have some question about also again on not fully probably answered about stages on DRI and NRI, so the network and the direct. Why we I think Jean-Pierre already answered on that. It happened that we had to address first the direct remote identification topic, and the network remote identification is coming, and we will address it in a short or medium term. But okay, it's not. It seems it's not clearly. It's not clearly answer to the people probably. Any additional information about the timing when the NRI will be addressed and how we'll try to have something consistent between the two approaches? Antonio or Jean-Pierre?
No, sorry, not today. I mean, we are working and the Commission is working on the use space regulation, as you know. In parallel, EASA is also looking to the NRI. I don't know if we still have Natalie here, but no detailed information, work in progress.
Okay. What else do we have? Actually, the experts are pretty good to answer most of the questions.
Do you think we covered the majority of them?
I think, yeah, for the others we can answer because they are very specific questions. So it's difficult to have a generic general concern.
Jean-Pierre, Antonio, do you still have a message to pass? I think we are coming close to the end of the workshop. Maybe I let you have a few last words if you have something to convey.
Perhaps before last word, I saw a question which I think it was interesting for security purposes about the possibility to detect upcoming drones when you are not connected from the beginning, and the time needed to detect such drone. I don't know if any test has been done on that. It would be interesting for security purpose. Really, when you are watching and then a drone, that you do not expect is coming, how much time you need to connect and to detect, and with respect eventually to the speed of the drone. I don't know if anybody has an answer to that. If not, this would be useful for, I think, again, security people to have this test as well. We should, of course, this function address privacy. Privacy will be mainly addressed indeed with standard mobile devices, mobile phone. But for security purpose, we may have, as indicated, special devices, and the performance in this case would, I'm sure, also be useful for security forces to know how they can use the function and how, to implement this, which I would really like them to do. They would need also some more information, like you have presented for, let's say, when people are using a simple smartphone. So just a recommendation to the group would be useful, I think, to promote this towards security forces.
Okay, I think Thomas, you answer partly to this question, right?
Yeah, I mean, I can say a few words again on it. I mean, what we showed in the video is basically we achieve a typical update rate of a few seconds, so 1, 2, 3 seconds, or even more frequently. It depends on, of course, on the environment, but there is no difference between the update rates or how often you receive the packets for an unknown drone or a known drone. There is no difference. So the pickup time for a new drone being started a few hundred meters away would be just within a couple of seconds. So the only requirement you have basically is that you get a line of sight to the drone so that you can receive the signal. So if there's an obstacle like a house between you and the drone, of course you won't see it, but then as soon as you have line of sight, you will receive the signal within very few seconds. There's no delay.
Okay, thank you very much. So final word on my side, if you allow. I think we at the Commission, we are happy to see that this function is materializing. You have demonstrated the feasibility, the fact that it is both, let's say, on the receiver side and on the drone side, something which can be implemented, both for privacy, and of course, this function in the case of privacy is more limited, like you need to be in line of sight, which is in fact very, let's say, coherent with this purpose, because if the drone is not in your line of sight, you cannot also be observed by the drone, and then no need for you to be aware of the presence of the drone. So this is fully, let's say, compatible. And on the other side, the security people can indeed have more, let's say, advanced detection means that would help them to detect drones in a way more appropriate to their needs. So I would really, I mean, thank you for this work. I would really like to insist on the fact that we believe that this function would make drones, let's say, much more acceptable and friendly, I would say, to the public. We strongly believe that this is a function which would promote and not prevent the development of the drone service market, that we will really support operation and operators and not, let's say, prevent them from additional and put on them an additional burden. I would really expect to see now this implemented in the drones. We still have a number of questions, as you raised, to be solved, and we will see how this develops. But I think this is a really good indication that we are going in the right direction. Yeah. Thank you from my side.
Okay, Christophe and Lionel, do you have few last comments, few last things important which come back from in your mind that you would like to raise before I start closing the webinar?
Not on my side. I think it was we collected a lot of interesting questions on privacy and so on that can allow to further develop the standard for the future. So this was very valuable to have this information exchange today. Thank you for all participants who contributed to improve our understanding of the needs and concerns of the community. Thank you.
Okay, on my side, same thing. Yeah, it's okay. I'm very happy to of all this information. I told already that it was this webinar was highly informative. It's not the common way to proceed to promote standards. So I think we understood all of us that it's quite a challenging topic, and for public acceptance of drone and future application, and also to make the authorities more comfortable. Of course, there are many work to do again, and still ahead. But okay, it's a good. Fully agree with Jean-Pierre. It's a good, it's promising approach. And okay, and again, so we'll go through again the question with the group, I guess, and see what's expected by the community. And again, you have the right to contribute and to comment the standard. It's still an inquiry up to the end of the month. So for everybody who wants to contribute and to comment this standard, please go ahead. And we have more work to do, certainly, at the end of it's a work group, but it's part of the job. Okay. Thank you for the organization. Yeah. It's perfect. And
thank you to all for the contribution. I think it was very good package of information and very complementary information. As we said, we will answer in a kind of question list, and we will put the replies to the question in written on the website of SEN and ISD STAN, probably also the white paper Lionel was referring. I think there is not much to say, very few words about an important step for SEN and Senelec. We have, it has been difficult last year to progress this strategy, but due to the COVID, of course. But we have recently published our strategy 2030, which aim to re-emphasize the importance of SEN and Senelec being a key actor in the support of the legislation, the industrial policy, the economy of Europe, also connecting with various perspectives like innovation, like the citizen, because in this present workshop, we clearly identify a need of being aware of the needs of the consumers and the fear or whatever coming from the consumer. So this strategy is really giving the reply to all those questions and defining what we are committed to do for the next 10 years. So you have, of course, access in the website. You will find it quite easy. So I will not go further on that. So I think it's time to close. You will get the recording. You will get all the materials which is publicly available. And so I just have to tell you goodbye and enjoy using and developing our dear UAS open category. Bye-bye for now.
Thank you. Bye. Bye to everybody.
Thank you, Thierry. Thank you to all the audience. Thank you.